So welcome everyone. Today we'll be solving the CCC 2020 J4 question titled Cycling Shifts. Now we can see here that Tuke likes finding cycling shifts of strings, and a cycling shift of a string is obtained by moving characters from the beginning of the string to the end of the string. Now the string itself is also considered to be a cycling shift. So the cycling shifts of the string A, B, C, D, E you see are A, B, C, D, E, which is by itself, and then when you move the A to the end, you get B, C, D, E, and then A. So B, C, D, E, A is another cycling shift. You move the B to the end, you get C, D, E, A, B. Do the same thing, you get D, A, B, C, D, E, A, B, C, and then E, A, B, C, D. And this is the last one because if you move E to the end like that, you're gonna get A, B, C, D, E, but we already have that. So given some text T and a string S, determine if T contains a cycling shift of S. So in our sample input 1, we have our text this, which is just a bunch of characters, and we have our string A, B, C, D, E. So if this piece of text right here contains any one of the cycling shifts of A, B, C, D, E, so if it contains any one of these 5 strings right here, then print yes, otherwise you print no. So you can see that the explanation says C, D, E, A, B is a cycling shift of A, B, C, D, E, and it is contained by this string right here. And then in the bottom right here, A, B, A, none of the cycling shifts of A, B, A are inside this string or this text, so you output no. So now that we understand the problem, let's see the actual code. All right, so looking at the code, the first thing that we have is a scanner object. We print out a line to get the input, and we say this string text is going to be s.nextLine. So that's going to be the text that we're going to check whether or not any of the cycling shifts of S1 are present. Then we have our actual string, which I called S1, is going to be that string that has all the cycling shifts. And then we have this boolean does contain, and we're going to set that to false, and it'll come into play later on. Next, we have this string array called shifts, and we're giving it the length of the length S1. And why that is because basically the idea here is shifts array is just going to hold all the different cycling shifts of S1, and we know there's actually a pattern that the number of cycling shifts a string can have when you're looking at this problem is the length of that string. So for example, if you look at this here, A, B, C, D, E, if that is our S1, it has a length of 5. And this string has 5 different cycling shifts, right? So in the same way, that's basically what we're doing here. We can also confirm this by looking at the other example. They gave ABA, which is a string. So the ABA itself is 1 cycling shift. And then you move the first A to the end, right here. So you move this A all the way to the end, and you get BAA, and then you move the B to the end, you get AAB, and then after that you would get ABA again, but that doesn't really count. So a string with length 3 has 3 different cycling shifts, and so that's why we're setting the length of this shifts array to s1.length. And the first thing that we do is we say that shifts at index 0 is going to be s1. So because s1 is a cycling shift of itself, we can automatically say the first cycling shift in this array is going to be S1, and so we're going to put that at index 0. Now, this block of code here, everything here is how we're getting all the different cycling shifts and then putting them into the array at the bottom. And here's actually a better explanation of how exactly this is working. Alright, so the first thing we're going to do is we're going to define a for loop, which is essentially going to allow us to put all the other cycling shifts of S1 into our shifts array. So it's going to start at 1. So here, let me just write it down here. So for, and we're going to say I. It's not proper syntax, but I'm just going to write it this way for the sake of simplicity. It's going to start at 1 equals 1, and it's 1 because it's not 0 because the 0th index of the shifts array already has that S1 string, right, which is a cycling shift of itself. So we're going to start at 1 to get the next official cycling shift, and it's going to keep running so long as I is less than the length of the array. So shifts.length, and it's going to go up by 1 each time, I++, something like that. And I'm just going to open the bracket, and I'll close it all the way down here just to give it some space. Okay, so what's happening inside this for loop? Every time that this loop runs, we're creating a new character array with the same length as S1. So we're going to create a new character array, we're going to call that C equals new character array, and same length as S1, so S1.length, like so. Now, the reason we're doing this is because so like for example, if S1 has a length of 4, for example, with the string such as A, B, C, D, and then let me actually just label this so you can see it better. So this is S1, our string, and then this is our character array C. So if S1 is A, B, C, D, and it has a length of 4, then we want to create a character array C with that like 4 empty boxes, that number of empty boxes, like so. Now after this, we define another for loop, and inside of this for loop, so basically this is where all the cycling shifts of S1 are obtained, and then the characters of each of those shifts are then put into the C array. So in this loop, we set our initiation, so for, and our initiation J is going to start off at 0, and we're going to have it running so long as it is less than the length of S1. So long as J is less than S1.length, like so, and then J plus plus. I'm going to open it, and then I'll just close it somewhere down here. Now, what's happening is inside this for loop, every time this loop runs, we have a statement saying, look at the jth index of C and give that a value of the character at the j plus 1 index of S1. So look at C at j, so the jth index of C, and give that the value of S1 dot character at j plus 1. Now, what that means is, at this point, right, we have an empty character array C, okay, with the same number of boxes as the string S1. So when j is equal to 0, what happens is C at 0 is now equal, so like the 0th index of C is equal to the j plus 1th index of S1. So C at 0 is now B. And when j is equal to 1, C at 1 is now 2. Oh, sorry. C at 1 is now C. There we go. And that means when j is equal to 2, C at that index is now D. And when j is equal to 3, this means that C at the 3rd index would equal S1 at the 4th index. But we can see that S1 doesn't have a 4th index. And so we have to put a check inside this for loop saying if j plus 1 is larger than the last index of S1, or we can represent that as S1 dot length minus 1. It's just a way to represent the last index of any string. What's going to happen is assign C at j. So C at j is equal to the value of S1 at 0 is equal to S1 dot character at 0. And so in our example right here, C at j or C at 4 would then equal S1 at 0 or A, like that. Now, you can see here that this is the first official cycling shift of S1. Now, getting the next cycling shift for S1 after this requires you to use the current cycling shift of S1 as S1. So we're repeating the same process, but now S1 is whatever's inside this C array, right? Because S1 can't equal this, otherwise we're going to get the same cycling shift. So we have to use this. And so getting a string representation of the characters in C, assigning that to S1 for the next iteration of the for loop is a very important step. So how do we do that? Well, if I just go to my eraser here, let me just erase this bracket. So this is basically our inner for loop, or smaller for loop, so I can actually just end it right here like that. It's a terrible bracket, my bad. But now we're back inside the bigger for loop, and we come back to the bigger for loop where we get the string representation of the array, which can be done using the value of method. So we're gonna basically assign that to a string. We're gonna call that shift. So string shift right here is going to be that shift is equal to the string static method string dot value of C, and it's going to just give the string representation of C. So string, in this case shift, will be B, C, D, A. Now after this, we are going to then assign S1 to shift, so it has the proper value for the next iteration of the for loop. So we're going to say S1 equals shift like so. And so when it runs the next time, instead of using A, B, C, D as the example, it's going to use B, C, D, A, and then it will move B to that end, and then you'll get the next cycling shift, and so on. And lastly, what we're going to do in this sort of block of code is we're going to put that shift or that cycling shift of S1 into our shifts array, which is what the bigger for loop is doing, right? And so we say shifts, which is the name of the array, shifts at I is equal to shift. And that's basically like gonna put that shift into that array. And so at the end of this whole thing, our shifts array will have all of the cycling shifts of S1. And this right here is basically just the meat of the whole solution or the whole program. And so now after this, once you understand this, we can now look at the final steps of the solution. All right, and so once we have all the cycling shifts of S1 into our shifts array, we use a simple for each loop going through every single shift inside the shifts array, and we see if the text contains that shift, and if it does, then our boolean does contain that we defined at the beginning, it turns true, and we break out the loop, because there's no point in checking if all the other ones are contained in the text, right? As long as there's one, we're good to go. And finally, at the end, if the boolean does contain is equal to true, or value is to true at the end, then we know that the text contains at least one of the shifts of S1, and we simply print out yes, otherwise we print out no. Anyways, that's basically it, and we can actually see this in action. So if I just copy in that right there, and I go here, and I put in the input, we can get yes as the output, which is the expected output. And we can try out with sample input 2. So if I just run this again, put the input 2, we're going to get no as the output. And yeah, that's basically it. Now, is this the best possible solution for this problem? Absolutely not. In fact, I believe it's one of the most overly complicated, excessively long solutions you can get. But at the end of the day, this is what I thought of, or how to solve this problem. There's actually much better solutions out there, but as long as it works, right, I guess it doesn't really matter. I guess it's fine, right? And in fact, there's actually solutions where all of this is basically replaced with more or less 2 or 3 lines using the substring method, which is actually a very clever method or like technique of solving this problem. But this is the way I solved it, so hopefully you guys enjoyed. I really like this problem, and yeah, I'll catch you guys in the next one.